Okay, hello everyone. Another session A1, module 10, basic router configuration. So this module is almost the same as module number 2, initial switch configuration, the basic switch configuration. With this one, however, we'll be looking at the router and what are some of the configurations, additional configurations that we can have on our router. With the switch, I think you got introduced to how to navigate between the different modes that we have, the user exec, the privilege, the global. How do you configure the passwords to lock the user exec via the console? How do you encrypt passwords? How do you navigate sub interfaces, the line sub configuration modes? That is the things that you did with the basic switch configuration. With the basic router, is all of that. Add to that, we now have interfaces that needs to be configured with IP addresses. I think that's the only additional thing that we have. So this chapter is chapter 2. This module is module 2, plus in addition of interfaces, because routers now have interfaces, and those interfaces need to be configured with IP addresses and enabled so that your network might be able to have communication. Right. So module objectives. Our module objective is to implement initial settings on a router and the end devices. And we're going to configure the initial settings, configure the active interfaces on a router, then lastly, configure the default gateway. So this is a very short module. Configuring initial router settings. Right, so the initial router settings that we have, like I mentioned, is almost the same thing with what we had with the basic switch configuration. So you configure the host name, you configure the passwords. This is the password you configure. This is another password via the console. This is another password via the virtual lines where you secure your virtual terminal lines. Then after you do the configuration of all your passwords, you encrypt those passwords. And on my right, those are the configurations that you're going to be making. So I'm going to skip through this fast because it's everything that we did in module 2. After that, we all know the banner, you configure the banner. So the same settings or configurations that you had with the switch, the basic and initial settings that you have with the switch are the same that you also have with the router. You need to give your router a host name. You need to have passwords on your router so that you can control access. You need a banner on your router as well as you need it on the switch. And these are the steps that you go through to do that. That is an example of a router which is being configured. We can see from the configurations, it has been changed the host name to R1, enable secret class. That's the password that logs the user exec, line console, password, etc., etc. We're sort of repeating everything that we were saying just before. This is an example of a configuration that is made. And after that, most importantly, let's look at copy running config startup. Very important, saving your configurations. In chapter 2, module 2, we talked of moving configurations from the running configurations to the startup configurations. Running configurations, you have the RAM, which is volatile, which means if your switch or your router reboots, reloads, switches off, you switch it on again without saving those running configurations, without moving them from the RAM to the NVRAM, they will be deleted. So it's very important to move your settings from the running configurations to the startup configuration so that when you reload your device, those settings are still there. They don't disappear because you didn't save them. Very important. Right, moving on. Configuring interfaces. I think this is where the main focus on router configuration should be. Configuring the interfaces. So what do we have here? With routers, with switches, they are layer 2 devices. A switch, we call them layer 2 devices. Then our router is a layer 3 device. What we mean layer 2 and layer 3, it means it operates at layer 2, the switch, the router, it operates at layer 3. The switch operating at layer 2, it means it uses the MAC address. That's where we should focus on. It uses the MAC address to determine the destination for sending its files, for sending its frames. Layer 3, the router uses the IP address to determine the destination for sending its packets. Layer 2 devices, when we did the basic configuration for the switch, you see it was not necessary to have an IP address. I think I mentioned it. No IP address here. It was not necessary to have an IP address. Why? Because the switch is a layer 2 device. It operates without having an IP address configured on it. Straight out of the box, you can take the switch, put it in a network, and it is functional without even having any IP address in the settings. Why? Because it's a layer 2 device. The MAC address is a physical address, is already there on the device. Therefore, the switch is able to perform basic communication without having an IP address. However, there is an IP address that we configured on the switch, which we call the SVI, Switch Visual Interface. We created a visual interface, which we gave an IP address. The reason why being for remote configuration of that switch. Right, when we talk of remote configuration, the initial configuration will use the console. You connect your switch to the console, you get access to your switch, you do your basic configuration. But what happens when you are not physically there with the switch and you want to make some changes to that switch? We have to create a switch visual interface, which we give an IP address, and we also give that switch a default gateway, so that when we want to remotely monitor it, we can be able to remotely monitor it. So layer 2 devices, no need for IP address to do the basic communication. However, an IP address is configured on a switch visual interface so that we can be able to manage the switch remotely. For layer 3 devices, that's a different case. Without IP addresses, there is no communication. Because we have interfaces, right? Let's have this is my router. We have interfaces. Let's have this interfaces, Giga interface 00, Giga Ethernet. We have another interface, Giga Ethernet 01. Those are my interfaces. If those interfaces are not enabled, therefore there is no communication between the networks. You can have a network here. Let's say I can have a switch. I can have a switch on this side. Then I can have multiple devices here. 1, 2, 3. I can have multiple devices here. 1, 2, 3. This is a network on its own. And this is also a network on its own. Every interface on a router represents a network. That definition might change as we go from CCNA 1, 2, 3. But for now, every interface represents a network. Within those two networks, these 3 devices can communicate with each other using the switch. The reason why switch is a layer 2 device, therefore communication within the network is possible. Communication within devices 1, 2, 3 is possible. Let's say 4, 5, 6. Communication between the devices 4, 5, 6 is possible because they can communicate via the switch. However, if devices in these 2 networks want to communicate with each other, it will not be possible without enabling these two interfaces, without giving them an IP address and enabling those links. So that is the difference between the switches and the routers. The routers enable us to communicate remotely. Devices 1, 2, 3. If device 1 wants to communicate with device 4, and they're in two different networks, there is a router that is needed there. Without a router, there will be no communication. Now that there is a router, the interfaces needs to be enabled. Now, how do we enable those interfaces? Here are the commands that we have. You go to the interface, command interface, you type the interface that you want to configure. We have different types of interfaces that we have on our routers, depending on the type of the router that you use. You will see Fast Ethernet, that's an interface on a router. Fast Ethernet, you can have Giga Ethernet, you can have serial interfaces as well. I think these are the three major interfaces that you will see on our routers. And this is the type of the interface on my command here. The type, it can be Fast Ethernet, Giga Ethernet, or serial. Then the number, the interface is also identified by a number. You see the numbers can be 00, can be 01, can also be 000, can also be 001, depending on the interface that you have. So you type in the interface, you configure the description. And what is the description? From here we have, it is a good practice to use the description command to add information about the network connected to the interface. So as I was saying, let's say we have our router and we have two networks. This is our router, we have two networks, network A, network B. This is Giga Ethernet 00, this is Giga Ethernet 101. The description on this interface 00, I can say description link to network A. It gives me an idea of what the link or what the interface is. When I do troubleshooting, for example, and I try to show all my interfaces, I want to see which interface is not working. I can see Gig Ethernet 00 is not working. What is that interface? The description will give me an idea what that interface is. It's a link providing network to LAN A. So that is basically what the description is. It depends on the administrator what the description can be. So that solely depends on the administrator, but it should give an idea of what the link or what the interface is supposed to be doing in the network. In this example, Giga Ethernet 00 provides network to LAN A. Gig Ethernet 01 provides network to LAN B. And those are my descriptions. So make it a best practice. When you configure an interface, you configure the description. After that, you then configure the IP address. You can see the command IP address. Then you put the IP address in the subnet mask. In the next module, we'll discuss more of what the IP address and subnet mask is. After that, if it has, the interface can have an IP version 4 address or an IP version 6 address. So you can configure both if you do have both. But in practice, you see mostly we'll be using the version 4. After that, we have the command no shutdown. And the no shutdown command activates the interface. It's like opening and closing the door, right? No shutdown. Shutdown is closing. So these are my interfaces A and B, 00, 01. If I look at this interface 00, and it's currently configured shutdown, it means even if the IP address is configured, the door is closed. Therefore, no packets can go through that interface. So to open that door, we have the no shutdown command, which allows us to open the door, and therefore packets can go through that interface. So it's very important, after configuring your IP address, you then configure the no shutdown command so that your interface is enabled. So this is a typical, very simple. This is the typical configuration of an interface. You see this a lot, you'll be repeating this a lot. This should be the list of your problems. Right. Configuring router interface example. Right, there we have an example. Right, we are going to configure router number one. This is router number one. It has two interfaces, Giga Ethernet 000 and Giga Ethernet 001. Those are the two interfaces that we have. What are the IP addresses? You can see from this network, that is the network that we have, and the IP address is .1 for Giga Ethernet 00. It means in full, the IP address on this interface is 192.168.10.1. /24, that's the prefix length. That will be our subnet mask. We'll get there in the next module. And for this one, so this is the interface, and this is the IP address. For this interface, the IP address is 192.168. No, it's not 192. The network is right here. It's 209.165.200.225/30. Those are the IP addresses. And how do we configure those IP addresses on router number one? These are the commands. Router number one, we enter the interface 000. The description, link to LAN. This is our LAN. This is our LAN. So it's a link to this LAN, right? Since there is no other LAN, this is not a LAN here. This is a WAN. This is a wide area network. Since we don't have another LAN on the other end, it makes sense that the description just says link to LAN. But it can be more explicit. What's the name of that LAN? Link to LAN A, link to LAN B, link to department sales, link to department networking, link to department electrical, something like that. Then we have the IP address, 192.168.10 IP address, that's the command. Then we have the IP address and the mask. When you input the IP address, it goes together with the mask. We also have the IPv6 address, which is right here, and the network is right here. We also have the no shutdown command so that we activate the link. Then after that, you can exit because you are done with the interface. On the other hand, we can also enter the interface Giga Ethernet 001 so that we configure this interface. IP address, another command. IP address, after the description, obviously, 209.165.200.225, and the subnet mask /30 is 255.255.255.252. Then after that, I can put the description. I say link to one, which is my wide area network. Then I can have my no shutdown, no shut, then exit. So on the other side of the link, I can configure this, I can have these configurations, which are not there in the example, but adding to what we have. So this is the how you configure an interface. Very simple commands. One, you enter the interface sub-configuration command. You configure the description, you configure the IP address, you configure the version 6 IP address. If it is there, no shutdown, opening the door to the network, exit, you are done. Continuation. Right, this is a continuation. Okay, this is what we did. This was the addition that I did in the previous slide. Now we are configuring the 001 right here, the 001 interface. The description, link to ARA2. In my previous slide, I said link to wide area network. Here is link to ARA2. Makes sense. We have the IP address. We have the version 6 address, no shutdown, exit. So now you've configured both these interfaces. Now, if you want to send a packet from PC1 to another PC, another laptop here, PC2, it's now possible. Why? Because this door is opened. Door A is opened, the interface is opened. Door B is opened, the interface is opened. We also go here and open door C. We also go here and open door D if they are not opened. So configuring an interface is like opening the doors of the network. All the doors are closed. When you configure the interface and you enable, it means you've opened the door to another network. Then we can send our packets, communication goes remote from that side. All right. The table summarizes show commands. After you are done with configurations, we have what we call show commands. And what show commands does is show us what you have configured. In module number 2, I think the most used show command that we had is show run configurations. We had show run. And show run showed you have changed the host name, you have input passwords, you've changed passwords on the line console, you have your switch visual interface configured, all your interfaces are there, you can see them. Everything that you have done on the basic switch configuration, you can see them when you have the show run configuration. Show running configurations is the same thing after making interface configurations. We can have the show IP interface brief command. The show IP interface brief command, what it does, it displays all the interfaces, their IP address, and their current status. We have an example. We have the show IP route, which displays the routing table. We'll get there. Show interfaces, show IP interfaces, show IP version 6 interfaces. All these commands, you need to understand what exactly they show. You see, however, they probably show the same information. Most of them, they have the same information, but you need to know how and which command to use to get the information you want. For example, if I want to see what are the IP addresses that I've configured, I can get them from almost all these commands. But I can probably choose to use this one, show IP interfaces, and I add a brief at the end. And you see the information that I get, it's only about the interfaces that I've configured. The interface Giga Ethernet 000, what is its IP address? That's the information that I will get. So you need to learn and understand which show commands to use to get what information that you want to get. Let's look at a couple of examples. We have the show IP interface brief. Voila. This is what the show IP interface brief gives me. It gives me the internet type that I have and the IP address. It also shows me the status and the protocol. The status and the protocol, you'll see it can be up or down. The status basically, the status shows us if there is a physical connection or if there is a physical device on the other end. So I can have something like this. I can have a PC here, PC1, I can have a router, right? I can have another link, and there is nothing here. Even if I activate this interface, since there is nothing here, you see the status will be down because there is nothing on the other end, no connection on the other end, even if the interface has been enabled. But if there is no connection, the status will be down. So the status shows you if there is a physical connection on the other end of the device. Then the protocol, it shows you if the layer 2, that is the data link layer, is operational. Most of the times when you do have a device here, let's say we have another device, a router. Let me see. So we have a PC. Now instead of having nothing, we have another router there. It means the status goes up because your interface can detect there is something on the other end. There is a connection, physical connection that is there, and there is a physical device on the other end. Therefore, the status goes up. There is brief communication between the interfaces. The protocol goes up as well because the layer 2 data link layer is now operational. If layer 2 is not operational, it still shows down. There is something wrong with your network. Probably you will not be able to communicate. Very important to understand the difference between the status and the protocol and what happens if the status and the protocol is down or if one of those two is down. Very important. Administratively down. This is exponent as well to understand what administratively down means. Administratively down, when you talk of administratively down, that is what we call the admin state. And it is determined by if this interface is enabled or disabled. And it is this one determined by the commands shutdown and no shutdown. So if the interface is at no shutdown, it means it is enabled. Therefore, it is administratively up. If it is shut down, the interface is disabled. Therefore, it is administratively down. So you can see the VLAN interface, VLAN 1, it is administratively down because we did not activate it. So very important. That is the information you get from show IP interface brief. The same with the version 6, we can get that same information. All right. Show IP interface brief. Okay, it's the same command. Show IP route. Show IP route, it shows us, I think this is a more complex topic to discuss. This shows you the routing table. It shows you the networks that the router knows. We'll get to routing in the later topics, but the show IP route basically shows you what does the router know. The router, its basic function, it allows communication between remote networks. A, B. If a device in LAN A wants to communicate with a device in LAN B, those two are in remote networks, therefore they need the router to communicate. Now the router needs to know where LAN B or LAN A is. If it does not know, then it's not able to send information to that LAN. And how do you see what the router knows? You see what the router knows by having the show IP route command. And from the commands that we have here, we can see that router A is connected to the link to this network, 192.168.10.0. It's connected to that interface, 192.168.10.1, connected to this network and connected to that interface as well. So if you can go and look at the addresses that are here, it's the same addresses that are, let me go back. Let's go to our topology, right? It's the same addresses that are here. So this was C. The router knows and is directly connected to this network. So the router knows this network. The router also knows the IP address of this interface, which is local interface. It also knows this one, it's a local, and it knows this network, it's C. So with our CLCL, that is what you see right here on our show IP route. These are the interfaces that you see here. So the show IP route gives you an idea of what the router knows. Show commands, very important. Right. Show interfaces. Show interface, it gives you a lot of information. You need to be able to identify the information that you need. Most of the information that is here, you probably learn about it, CCNA 3, CCNA 2. But I can identify from what you've learned so far. I can identify, let me see. This is the IP address of the interface, internet address. I can identify that. I can also identify, let me see. I think that's the only thing that I can identify at this point that we have configured. We have configured an interface and the IP address is right there. I can also use show IP interface brief to give me what the IP address is. So those are two commands that gives me an idea what the IP address is. But you need to be able to use them interchangeably depending on what information you are looking for. So you can see we have information about the speeds. I can see the speed. This interface is in full duplex mode. Speed of link speed 100 megabytes per second. Right? Very important information that I can see from there. But we will learn as we go. Lastly, we have the show IP interface. Important information from this section. I can get the IP address. Different show commands, but I can still get the same information from there. It also have a lot of information that is there that as we go from CCNA 1, 2, 3, we'll be able to deduce what that information gives. Right. Show IP in IPv6 interface. So from the show commands, you can see there is a command with show IP, then there's a command with show IPv6. The only difference between these two commands is one shows for IP version 4 and the other shows for IP version 6. These are two different protocols that are used at layer 3. The first one, it uses, these are the numbers that you can see, 192.168.10.1. This is IPv4. The other one uses the hexadecimals. So you can see from this number, 2001 TB8 ACAD, that is an IPv6 address, which we'll get to as we proceed. Configuring the default gateway. All right, what is the default gateway? The default gateway is the gate out of the network. When we configured, let's look at this example. Or let me start by reading this. The default gateway is used when a host sends a packet to a device to another network. The default gateway address is generally the router interface, okay, to reach PC3. Okay, we'll explain that. The default gateway is the gate out of the network. Out of the network. Every device in a network needs to know, if I'm sending a packet out of this network, which gate should I use? So if PC1 wants to send information, let's start with wants to send information to PC2. There is no need for a gate. Why? Because this is the same network here. Every interface on a router represents a network. So this interface represents one network. This interface represents another network. So if I'm sending from PC1 to PC2, no need to even involve the router. I can use the layer 2 addresses and I can have communication. However, if I'm sending from PC1 to PC3, these two devices are in two different networks. Now, PC1 needs to know which gate should I use to get out of the network. And the gate it uses to get out of the network is this interface right here. So when you configure your configuration on PC1, there is a configuration where you tell PC1, if you are sending a packet out of the network, the gate you use is this one. And the address is 192.168.10.1. I can see from this network, I can see from this one right here. Right. So that is the gate for PC1 and PC2. That is the gate. For these PC3 and PC4, they will use this gate right here. And the network is 192.168.11.1. That is the IP address of that gate. So when you configure your devices, every device in a network, it needs to be told what is the gate out of that network. And that is what we call the default gateway. If that default gateway is not configured, therefore the device will not be able to communicate remotely. That's where engineers get administrators, probably not engineers, but that's where administrators get to do their work, troubleshooting. You go to PC1, does it have a default gateway? No, it doesn't. You just go and type in 192.168.10.1, you get paid. Default gateway, very important, the default gateway. The same thing with the switch. When we did our switch visual interface in module 2, we configured the IP address and we also configured the default gateway. The reason why we configured the default gateway is because we were telling the switch, this is the gate out of the network. So if you want to manage your switch remotely, communication will be via that gate. If you don't tell your switch what is the gate out of the network, you won't be able to connect to that switch remotely. So this is basically what we have here. This is a network. All the devices in this network, all these three devices, PC1, 2, and switch 1, they need to be assigned what is their default gateway. And basically, this is what the basic router configuration has to show with us. And that summarizes our chapter 10. Let's meet in another session. Probably we'll discuss module number 11, IPv4 addressing.